A very good evening to all of you. So in the morning session, we talked about the nerve physiology. So we are going to apply the concepts what we learned in the morning in the evening session. So moving on, a 24-year-old man cuts his finger and immediately pulls his hand away from the pain. So which pathway is responsible for this response? See, there is a reflex mechanism in our body that does not require brain for its activity. That one reflex mechanism is called as the spinal reflex arc mechanism. Okay, the spinal reflex arc mechanism is one of the mechanism that does not require brain for its activity. So what does that mean is, so when someone cuts my finger, what happens is the information is sent to the spinal cord and the spinal cord gives the response. So it is not taken to the brain. So that is why when someone cuts the finger, we move it immediately, and even the pain is felt in the later only. So pain is felt only in the later stages. The first reflex what we will do while someone cuts the finger or while we accidentally cut the finger is we'll move away. That reflex is called as the protective reflex. That is called as the or flexor reflex. That is the spinal reflex arc mechanism. It is one of the mechanism that does not require brain for its activity. Okay. And what is corticospinal tract? Corticospinal. So it is one of the controlled activity. Say for example, I want to move the machine, I want to move the chair, I want to move the pen. Okay, so that is one of the controlled activity, voluntary movement. So the brain sends signals to the spinal cord to move this pen or to move the any kind of objects. So this is one of the voluntary movements. Spinothalamic tract. Spinothalamic tract carries the pain, temperature and the touch to the brain. Okay, and the dorsal column pathway, it carries what is called as the vibrations. So this is how the various parts or various tracts they perceive the sensory informations. Okay, now moving on to the next MCQ, which of the following statements is true about an action potential? So action potential is self-propagating. Of course it is self-propagating. Release of neurotransmitter triggers the neurons. It follows the all or none principle. Yes. It requires minimum threshold potential. Of course the resting membrane potential, it should be it should make more a little or less positive so that it reaches the threshold potential of minus 55 and then it stimulates and then the action potential is stimulated. And of course it has a refractory period, absolute refractory period and relative refractory period. So all these statements about an action potential of a nerve is true. So the resting membrane gradient of a nerve membrane is dependent on, okay, see, I'll be rushing through these MCQs because I have already talked about the concepts in the morning session. If you want the concepts, you can just move to that video, watch it for 5 to 10 minutes and then you can come back again. So the resting membrane gradient of a nerve membrane is dependent on, we all know the answer. What is it? It depends upon the sodium. No, it depends upon the potassium. Why? Because see, imagine, of course the sodium goes out of the cell, the potassium comes in via the sodium potassium ATPase, but the main or the significant thing that is required for the resting membrane gradient is the potassium. Why? Because it is a potassium that is pumped in, and again because of the high gradient it goes out of the cell. See, one thing you have to remember is, as I told you, there is leaky potassium channels and leaky sodium channels. Okay, so the leaky potassium channels, of course the potassium goes out leaving the negative ion, and the leaky sodium channels, sodium comes in. But the thing is, the sodium coming in, it diffuses very less compared to the potassium. So potassium diffuses very fast and more rapid compared to the sodium. That is why even after the diffusion of the sodium, the resting membrane potential of a nerve does not becomes more positive because the potassium moves out rapidly out of the cell. So the resting membrane gradient of the nerve membrane is totally dependent upon potassium. Why I marked sodium at the first instance is most of the students get confused and they mark sodium. It is not sodium, it is potassium. Moving on to the next MCQ, a 30-year-old man is injected with lidocaine before extraction and he loses pain and then touch and then the motor. So what is the order? We all know: pain, temperature, pressure, touch. So this is how the order it goes on, and then the motor. So 1, 2, 3, 4, 5. This is how the nerve gets anesthetized. So before moving, the lidocaine, what is the function of a lidocaine is basically it blocks the sodium channels. So imagine there is no sodium channels. So if there is no sodium channels, will the action potential of a nerve takes place? No. Why? Because the resting membrane potential is not stimulated, or the resting membrane potential is not attaining the threshold potential because of the absence of the sodium influx. So the action potential is not going to take place. So that is how the lidocaine blocks the nerve conduction action potential. The release of the neurotransmitter is blocked. Okay, this is the first point. So lidocaine blocks the sodium influx. So when there is no sodium influx, there is no action potential of the nerve, there is no impulses. Okay, one. Two is, so imagine the lidocaine, it blocks the sodium channels, and if you have to make your common sense, if the nerve fiber is small, is it easy to block the nerve fibers? Or if the nerve fiber is very big, it is easy to block the sodium channels. Of course, if the nerve fibers are small, it is very easy to block the sodium. And also if it is myelinated, it becomes still more easier because the myelinated nerve fibers will have myelin sheath in the axons. So it is not going to allow the the ions to stay there. It is going to get it to the nodes, that is the nodes of Ranvier. Okay, so imagine this is an axon. Okay, this is an axon, and this is the myelin sheath. This is nodes of Ranvier, and this is an axon. So the sodium channels, it will jump from one node to another node, saltatory conduction. Okay, so in a myelinated nerves, the ions are going to jump from one node to another. Of course, it is not going to jump, it is going to push, but we say that it jumps. So it jumps from one node to another node, that is called a saltatory conduction. What happens, it is very easy for the lidocaine to block these kind of myelinated nerve, because it blocks here, it's enough, it blocks here, it's enough, it blocks here, it's enough. Imagine in unmyelinated nerve, the sodium will be present throughout the axon. The sodium will be present throughout the axon. So it has to block here, it has to block here, it has to block here, it goes on. So it will be very difficult for the lidocaine to block an unmyelinated nerve fibers. So if the nerve, so two things. One, if the nerve is small, and if the nerve is myelinated, it will be very easy for the lidocaine to block. That way, A delta fibers, they are small myelinated fibers. It gets blocked. It is the one that is responsible for the sharp pain. The lidocaine first blocks the A delta fibers. C fibers, of course it is small, but it is unmyelinated. Okay, so it carries dull pain. The next to A delta fibers, C fibers are blocked. Okay, the A alpha fibers are extremely large fibers. Okay, they are extremely large and deep rooted myelinated fibers. So it carries the impulses to the motor system, motor neurons. So it is not that easily anesthetized by lidocaine. And A beta fibers are medium to large fibers. Okay, so out of these fibers, the A delta fibers are blocked by the lidocaine very fast because it carries a myelinated nerve fiber, and it is very small. So it is responsible for sharp pain. Okay, now moving on to the next MCQ, that is the last MCQ. The patient has numbness after prolonged pressure on the arm while sleeping, and the sensation returns after a few minutes. We all would have felt this, right? So what happens if I sleep on a particular arm for a prolonged period of time? What happens? The blood supply in the arm is going to get decreased, right? Ischemia. So what happens in ischemia? There's going to be decreased blood supply. When there is decreased blood supply, there's going to be decreased oxygen. When there is decreased oxygen, there's going to be decreased ATP. What happens? When the pressure is relieved, it comes back to the normal. So in this case, the sensation returns after a few minutes, and the temporary numbness is caused by the reduced blood supply causing the conduction block. So because of the reduced blood supply, ischemia takes place, reduced oxygen. So because of the reduced oxygen, reduced ATP. So again, it is it is reversible one. So when the patient releases the pressure, it is going to come back to normal. So this is about the nerve physiology. So if you have any doubts, you can put it in the comment section. We are happy to answer that. So we'll see you in the next video. Until then, have a nice day and happy learning.